There you go. All right. Now the webinar is officially being recorded. Yeah, I've been asked a few times today if this will be recorded or not. Thanks for reminding me. All right, now it's 6:07. I think we can safely start the webinars. We have over 100 people on the call, which is great. So the webinar is recorded. Oh, first, let me do this. All right. Hope you all see the full screen instead of the presenter mode. So the webinar is recorded, and then I will upload the recording to a platform so you all be able to view it anytime you like. It's gonna be a long video, so just for your reference, it may take you a little bit of time to go through everything if you miss the live presentation today. So first of all, I want to appreciate everyone for joining the webinar tonight. This one is going to specifically focus on adjuvant, or drift reducing agent, or DRA, for drone spray. All right. So many of us have used DRA, and some of us do not use it. So there's a lot of different opinions about it. I have started to focus on this topic, and I have some interesting data. So I feel like this will be a good opportunity to present to the drone operators and also connect the drone operators with the agrochemical industry and the CPDA members. So they will be able to devote R&D and efforts into formulation and adjuvant specific for drone markets. I think that'll be a win-win for both sides. All right, before I present, a lot of people asked, this will be recorded to share later. Yes, this will be recorded to share later. All right. All right, Taylor, thanks for watching the chat box for me. All right, I need to throw out a few disclaimers first, just like all my public presentations. First, this one is open to the public, offered by land-grant university and extension system. We are non-commercial, non-biased. We provide objective opinions. So it is what it is. You are not obligated to buy anything after the call or adopt any of the recommendations if you don't believe them. So whatever you decide to do after the call today is totally up to you. I don't particularly care. I just want to let you know the data and also the findings from the field trials. And also, on the flip side, this is not a training. This is not a training that is suitable for people who want to daydream, or if you're looking for silver bullets. For example, if your expectation is, I want you to tell me a drift reducing agent. So as long as I use this DRA, I'm able to spray any type of environmental condition, even in the middle of a hurricane, and still none of the spray droplets will drift, and every single one will hit the ground. So I can completely forget about wind or everything. I can spray 24/7 anywhere, whenever I want to, and without causing any trouble. So if this is your expectations, I'll tell you what to do. Move your cursor down to the bottom, and there's a red button. There's a red button on the corner, on the right corner, says end of the call or end. Just click on that call and leave, All right. So you don't have to waste 2 hours listening to the stuff that don't meet your expectation. So that's what I want to say as well. There's only so much we can do to help you increase your efficacy to mitigate the drift issue. But if your expectation is unrealistic, this is not a training for you. And I don't think anyone will be able to help you eventually. So that's another thing I want to say. The third one is because I work for a public educational agency focusing on research and education. I am not able to endorse any product. I don't want to endorse any product either. So if I use some of the product in this presentation, it doesn't mean I endorse them. That's just the only thing I'll tell you is I work on these products for testing and research purpose. You know, it doesn't mean that this is the best thing out there. You all should use it. You all should buy it. You know, I have to work on some products, but also at the same time, there's no way for me to test every single product out there. Could be a couple million, different products or different formulations. So I'm not going to be able to provide you the answer. Which one is the best? Which way is the best? Which one is a bulletproof? I don't know all the answer. All right. Even though until I retire, I probably still won't be able to figure everything out. And also because it is a very new area, and I constantly work on new product, new concept, new data, not new equipment, and generate new data. So my perspectives evolve over time. Some of the things I say today may not hold true next year, if we have new product, new equipment, or new technology. So I want to throw out this as a disclaimer. And also, the last thing I'll say before we kick it off, be prepared to see a lot of data in the next an hour. I mean a lot. So one way to help you feel a little better if you're at home is go to your fridge, get a beer or get a glass of whiskey or whatever you want to drink and make it the way you like, and that may help you swallow this data a little bit easier. Having a little buzz may help you understand the science a little better. All right. I can't do it because I'm in the office because all I got is Red Bull. All right. So, but you guys have fun, whatever makes you feel comfortable at home. All right. For people like us, we're looking for problems to work on. So I'm not saying I'm real happy to see people screw up, but a lot of time we're sort of happy because they give us something to work on the research side. We all need to have specific focus and the reason why we're working on this type of issue. All right. So lots of you are on Facebook, and that's where we find most of the operators talking to each other, working on different issues, which is great. If you look at all of the questions being asked online these days, all right, most of those questions are related to equipment. Probably 50% of the questions are error message. Some error message shows up. I don't know what it means. My drone is not flying. Something is not working. What can I do? And that's the majority of the questions. And then a good chunk of question belongs to which generator is the best? All right, how do I make this workflow happen? How does this software work? Signal questions and trailer design, this type of stuff. I should say most of the questions are related to hardware and the software. It's all on the operation side. Sometimes you see people ask this type of questions related to spray quality, but it's definitely fairly rare. It's not common. So this is also one of my concerns. All right. This is a very new industry. We're getting all kinds of people from all walks of life getting into this business, for multiple reasons. A lot of them are shooting for a quick ROI, and they think this is easy. That's my biggest concern. Do they really know what does droplet size mean? Do they really know how to choose the proper droplet size and ensure the efficacy? Do they really know much about what each parameter, all the settings on the remote controller, what do they mean, and how do they impact your spray quality? A lot of people don't have an idea. This is why I posted a few days ago online. I said, for a lot of people have no idea, you could be one click away from total screw up. That's it, because you don't know what you're doing. And the new software, new controller makes everything so easy. You can change whatever you want to at the touch of a button, right? So let's look at this issue, and then I really need to move on to the data part. So this is the problem I want to bring up. Not going to disclose who this person contact me using private message. He's from South Africa. He left me a few voice message with that English accent. So he's not from the US. But the issue looks pretty common. So what he's trying to do is spraying herbicide. I think in this case, fluazethop, which is a fusilade. That's a grass herbicide, ACCase inhibitor, trying to control the growth bud on the sugarcane before harvest. He's not trying to kill the sugarcane, but he still need to, hurt the sugarcane, at least kill the growing spot. So he's spraying herbicide. And then streaking or grain streaking is a concern. He reported grain streaking, and then the parameters that he used are listed on the right-hand side. Let me change my pointer. All right, 3.21 GPA, around 20 feet per second, 11.5 feet above canopy, around 28 feet swath, 500 micrometer, and a fairly high rate of DRA in the tank. The reason to use 500 micron droplet size and 1% by volume, this is 1 gallon in a 100-gallon mix, was because he had a lot of concern about drift. He is so concerned about a drift, he was being very conservative. As soon as I saw this 500 micron with high rate of DRA, fairly wide swath, but not fast enough, I sort of know what happened. All right. So this is a case, a realistic case I want to throw out first. All right. How many of you really know what 500 or 400 micrometer setting on your controller is actually doing for you? Probably not a lot. I don't think even 10% of you ever tested yourself, So this guy certainly belonged to the 90%, didn't even test. Just assume 500 micron is better, bigger droplets, less drift, and put a 1% DRA in there. So that's maximum drift protection. Okay, let's do it. Let's spray. All right. You will see why I hit on this point pretty hard throughout the talk. All right. You think something works, and it sounds good on paper. Reality is different. You never done the testing, so you're going to live with the consequence. All right, so that was the video he sent me. Not high quality, but you can sort of see the grain streaks out there. So same talking point. When you don't know much about drone spraying and you don't find credible information online about how to spray, you might be only a click away from total failure. Your fancy trailer, your big powerful generator, your two-story, trailer and awesome drone will do nothing to stop it from happening. So knowledge is very, very important. Even though 80–90% of the questions are related to hardware, software, diagnosis, and issues, never neglect the fact that you get paid by the efficacy if you do this for a commercial business. All right. If there is no efficacy, why you waste your time on this, right? And also, even though you think you have experience in drone spraying, is your perspective and is your method most up to date and most effective to ensure sufficient deposition and efficacy? Are you really doing the best? That's the second question. And then the other question I want to ask everyone, and this is a statement from several experienced operators from Facebook that I see several times. So the statement goes, I don't use any drift agent unless wind speed picks up. And I don't see the value or benefit of using it when there is very little wind. Do you agree? Do you disagree? Or you don't have a perspective? What do you think about this? That's a question for you all. And I hope after training today, you will be able to have your perspective. All right, lots of data coming. Lots of data coming. All right, so I hope the audio and videos are okay at this point. I think chat box, somebody was saying something about audio or video issue, whatever. All right, ground deposition testing. Let's get into our core business, which is field trials. So to answer those questions, we flew T20P 5 passes on a 1.8-acre block. So each pass was long enough that I can achieve the high speed, which is 32.8 foot per second in the middle. Why do you use a T20P? Well, first, it's small and it's really easy to carry. Second reason is when we spray 1 to 3 acre testing plot, the size is very comfortable, 1 to 2 acre particularly. And the third reason is T20P has the same spray system, same rotary atomizer and the flow meter as a T40, So the droplet spectrum is the same. And I also believe the dew disc came with a drone is also the same on T50 compared to T20P and T40. So this is why we use T20P for like lots of deposition testing. We don't use T20P for slow speed deposition testing because propeller downdraft become an issue. Only when we fly fastest, when you minimize your propeller downdraft. So the results are very comparable from T20P to T40. We have lots of corn deposition data on yearly to prove that point. All right. So we flew fastest speed, 30-foot swaths, 10-foot high, very flat ground. And I have high confidence in this setting because we tried it so many times in field trials. In calm condition, it does a pretty good job. And we collected 3 transects of water sensitive paper. Each one is a 50 feet wide, 25 each one is about 40 to 50 feet wide, around 10 to 11 positions, about the 10 to 11 position. Those means 10 to 11 water sensitive paper. Then we measured a lot of things. We measured wind speed, we sprayed, and then we get a car spec, and we scan for a lot of data. We measure a lot of data on those water sensitive paper. Because of time limitation, I don't have time to play with the fluorescent dye. So lots of different treatments as well. So we tested water 2, 3, 4, 500 micrometer setting on the controller. Also, we put one kind of DRA with water at 3 different rates. So that results 9 different rates, from 3 DRAs. We also tested both 2 and 3 GPA. We also tested 2 and 3 GPA. We tested both 300 and 500 micron. So it is a bunch of different treatments. All right, so that was the day of the testing. That's my student helpers. It's a very flat ground, and T20P was only spraying water. So we don't have anything else in there, just to simplify the results. The atomizer on T20P is exactly the same as T40, and probably the same as T52. I think Taylor can confirm that later. All right, here is the whole list of the treatment, and there are lots of stuff out there. So I'm going to break this down and be a little slow on the front. For water, we sprayed 200, 300, 400, 500 micron with 2 GPA. All right, so that was the water alone. And then we put ultralock in the tank at a 3 different rate: low, medium, and high rate, percentage by volume. It's also spread 2 GPA, 300 micron. All the water and the 3 ultralock treatment were sprayed with 300 micron setting on the controller. And then we bump up the GPA to 3, remixed, and use a high rate ultralock, sprayed at 3 GPA using both 500 micron and 300 micron. So the 1% full rate of DRA at 500 micron at 3 GPA was the failure from South Africa operator on his sugarcane. So I want to replicate his failure, and actually I replicated 3 times here using 3 different DRA. All right. So the second DRA is Intec Pro. This is a natural guar gum-based DRA, pretty thick. This is why the use rate is lower. Ultralock is a man-made polymer-based DRA, so the use rate is a little higher. For Intec Pro, I had a lower rate, medium rate, and high rate. Sprayed at 2 GPA, 300 micron. And then the last one, which is the failure treatment. This is the highest rate of Intec Pro according to the label. I always read the label before you do testing. And it's sprayed at 3 GPA using that disastrous 500 micron setting. So this is replicate number 2 of the failure, of what happened in that sugarcane fail. The third one is called RAIN. This is a loveland or nutrient product. Also a polymer, polyacrylate. Low rate, medium rate, high rate, 2 GPA, 300 micron. Also, last one is highest rate, 500 micron, 3 GPA. So that operator screw up one time with that setting. I make sure I screw up 3 times so I can triple the mistake, and then I'll be able to tell you how to do how to do failure management. So that's kind of my perspective. If something gonna fail, let me fail first so I can tell you what not to do. That's all part of the job. All right, looking at the water sensor paper. Many of y'all have sprayed these before, but do you really know what you're looking at? After you look at a bunch of them, you will get a clue, whether this is good or bad. So this is a 2 GPA, I'll just tell you. All right, if you get this type of hits, this many hits, and the coverage for 2 GPA, I consider it as a win. It doesn't look bad, really. This is actually pretty good for 2 GPA. And then the treatment B, next treatment. You see, this is a treatment B, and you see droplet size are getting bigger. Droplet size are getting bigger. And also versus treatment A, if you put your head really close to the screen, you can see some of the real fine droplets on the water sensor paper. You can see them. When it gets to treatment B, you don't see that many fine hits. The area in between the big hits look fairly clean or look cleaner, or something happened here with treatment B. All right, treatment C, we're seeing that trend going to more extreme condition. Bigger droplets getting a little ridiculous. You don't have a lot of small fines anymore, but it's still a combination of big and small at the same time. This is just all water. All right. The last one is the failure. I don't mind telling you this up front. This is why I said part of this talk is failure management if things don't work. All right. So this is looking pretty ugly. Look at the size of that thing. That's almost like a soybean seed size. All right. That's definitely not ideal. And this is why that guy had a streaking problem. He probably hasn't run his testing before and just kept on using it. All right. Looking at the same treatment D. Yeah, it was ugly. I don't have other ways to describe it. All right. So let's look at water alone. 200, 300, 400, 500 micron setting on your controller, okay? So the VMD measures the median droplet size, goes higher and higher and higher, right? At a 2, 3, 4, 500 micron setting. So that's what it's supposed to be, or that's what how it's supposed to work. On paper, it looks fine to me, 500 micron gets you to above 450. And then if you look at the hits, and then the hits numbers start to go down tremendously. And this is why 500 micron create a bunch of big fat droplets. Those big fat droplets count a lot of coverage, but you lose a lot of hits. So percentage coverage is usually what we talk about most of the time, but percentage coverage can be misleading at the same time as well, because you can cover a water sensor paper by 2 ways. The first way is you have a lot of fine mist, cover the whole thing very uniformly. The second way to cover a water sensor paper and still get a pretty good looking percentage coverage is you have really big and fat droplets. Just 3, 4, 5 hits on that paper will get you enough coverage versus the first case, but that's very, very big droplets, soybean size, sometimes even quarter size. That's more like a leaking from the atomizer, and they just get flooded. All right, so that is not ideal at all. So this is why I say the percentage coverage on paper can be misleading as well. You could get some really big droplets, only 1 or 2 hits in a very extreme condition, get you really nice coverage, with the software. Because software doesn't discriminate or differentiate. You really have to look at the pictures and also look at other parameters to be able to tell. All right. We'll go a little deeper into the data. All right. I said you will see a lot of data in the first place as a disclaimer. So I hope you have a beer or whiskey ready. You either will find this part very exciting or to become a very big headache you have to swallow. But either way, this is the professional training a lot of the new operator needs to have. Remember, a lot of crop dusters laugh at the drone guys that you're a rookie or a newbie, you don't know nothing. This is a part of the learning. You have to you have to do to be able to respond to that type of comment. And not all crop dusters are like that, but occasionally we see one or two. All right, the chart on the left bottom shows the international color and the category of droplet size category. All right, so this information is readily available online, from extremely fine all the way to ultra coarse. Symbol, color code, and the range of micrometers. All right, so these are international standards you need to go by. I know when T40 was just released, the DJI, I don't know whose idea inside of DJI, they become real creative, and they put the droplet size setting as a very coarse, extra coarse, coarse, fine, very fine, something like that. Those were just completely ridiculous. Those things are more misleading than anything else. It doesn't mean anything. The actual coarse actually produce medium droplet size at the best. All right. So this is what international standards should look like. And then what is this pie chart? All right. This pie chart tells you the composition of each droplet size and also the volume that each droplet category delivered. For example, this yellow one means medium droplet size. So this is a really good range. See yellow, medium, and medium, yellow color pie chart. The yellow portion of the pie represents 226 to 325 micrometer in terms of size. This is really a nice range for us to achieve high efficacy without drifting too much. I'm hoping this yellow portion would go bigger. Right now, the data says when we spray water at a 200 micrometer at 2 GPa, 29.2% of the tank volume we sprayed was actually applied by the medium droplet size, which means if I sprayed 100 gallons of tank mix, 29.2 gallons of my tank mix was delivered to the crop by medium droplet size within this range. I'm going to stop for a second to let y'all think. This is very important, all right? We want ideal range of droplets to deliver chemicals to your target. Mediums are very ideal. I can live with fine too. Fine is actually better in terms of covering more area with same amount of volume. Coarse droplet, not too bad. The issue here is the red, which means very fine, and the purple, which means extremely fine. Very fine and extremely fine usually contribute to your drift problem. And also they are subject to the evaporation. They're too small. So during the free fall period, especially in hot and dry conditions, they'll just evaporate. They'll never touch the ground or deliver the chemical to the target. And also, if you have a lot of a black color portion of the pie, that means your droplets are way too big. Those are ultra coarse and bigger, very, very big fat droplets. So when we do 200 micron setting with only water at 2 GPa, this chart shows you the distribution of the spray volume, the volume of those droplets carry across the range of the droplet spectrum, anywhere from 0 all the way up to 763. So based on our data, 3 reps, 33 samples, 200 micrometer setting create a droplet spectrum looks like this. This is not the best thing in the world, but I can live with it. At least I can see the middle of the peak is probably around 200 micron, which is not too bad, all right? And also, this is also my question. If we want to improve this curve and make better equipment, so how should this curve look like? I will see if I can do this. Can y'all still see my screen? Because I exit the full screen sharing. Oh, they say nothing. So I assume it's good. Can you still see my slides?
I can see it, Steve.
Okay. All right. Thank you. So how can we improve our equipment and make this curve look a little better? This is a rotary atomizer. All right. So that's the equipment manufacturer and other scientists' job. That's not my part. That's engineer's job. But what I like to see is this curve will look like this in future. At the very small, at the very small droplets, this line will be very, very low, almost none. And then when it get close to my target micron size, this become a very sharp peak and start to go down and look like this. Okay, y'all see my black line, the new peak I drew?
Yeah, got it, Steve.
Okay, good, good. This will be very, very ideal. Again, this could be my daydreaming as well, only exist in theoretical world, you know. This will be super because the peak is centered around your target VMD. Oh, sorry, this is a terrible straight line. All right, if my VMD is right here, this sharp peak tells me I deliver most of my chemical mix using the exact same droplets that I want it to be. This is perfect. Versus this is a long range of droplets. So I'm delivering chemical using a little bit of every size of droplets. All right. So again, this may or may not happen, but look at the red line again. This is actually not too bad until you see the next one. All right. Okay, go back to full
Hey,
screen.
Steve, we got a question on that last slide.
I probably don't have time for a question. We'll leave the question to the end, you know, and I'll make sure I will address it.
I think just clarification on the y-axis, maybe.
Mhm. Oh yeah, yeah. Mark Leber said it correct. Yeah, I probably didn't say this correctly, Mark. Thanks for correcting me. That's the diameter. Yeah, that's the diameter by volume. Yeah. Will? Yeah, yeah, it's a little bit difficult to see. But anyway, yeah, either way, the volume here, I think Mark may be correct, you know. The volume here is the drop. The volume here means each droplet, the size of each droplets that carries, you know. So if most of the droplets belong to 200 micron in the last case, if most of the anyway, all right, it's not working too well. All right, let's hope this thing is not dead. There we go. All right. Again, this chart will show you the spectrum, the droplet spectrum, you know, based on the size of the droplets. You know, we want more droplets to be around our VMD, which is the target range, which is a target range of the operation. And then if more droplets is sprayed around this VMD, so that'll be very ideal. So this peak will be a little higher, you know. And then if you look at this chart, right, this chart shows you a few categories. So there's AMD D.1, VMD D.1, and D.9. All right, so this D.1, I actually call it DV10. It's the same thing. So this means 10% of your spray tank was sprayed, or the volume in a spray tank was sprayed by droplets smaller than this mark. All right, so this contributes mostly to your driftable fine. The VMD means the medium droplet size that you deliver 50% of chemical. So 50% of the chemical in your tank was sprayed by droplets smaller than your VMD, and the 50% of the volume was sprayed by droplets bigger than the VMD. So VMD marks 50% of your tank volume that you sprayed, or the total volume that you sprayed. D.9 or DV10 means 90% of your tank volume was sprayed by droplets smaller than this. So over here represents 90% of your tank. So if your tank is 100 gallons, you spray it out. 90% or 90 gallons were sprayed with droplets smaller than that. So this will tell you the biggest droplets. So 10% were delivered by the bigger droplets, bigger than this. So that's what D.1, D.9 means. So the interesting thing is if we compare water to backpack boom, I don't have time to pull my T30 out and do the fly fan nozzle, do the fly fan nozzle. So I just use backpack boom with the 4 nozzles to spray. All right. So with the 15 GPA, 3 mile per hour, 45 PSI, and this is a fairly small nozzle. This is the composition of the droplets that we found using the traditional XR nozzle. This is the same pie chart from the last one. If you look at the composition of different color, they're very similar. So DJI didn't do a bad job at 200 micron, all right? So if you look at the D.1 or DV10, the VMD, the D.9 of the Roto atomizer versus the XR nozzle, it wasn't too much of a difference. It wasn't too much a difference. All right. Something I noticed is the D.9 minus D.1. So this 319 micrometer range is the distance between this line and that line, and this line right here. So this number means that 80% of the volume you sprayed was delivered by the droplets fall into this range. So this range will be the narrower, the better. So this is why I drew this black line in the first place. This range, so if DV10 is right here, DV90 is right here. So DV90 minus DV10 measures the distance here. The smaller this distance is, the better. All right. So we got 319 micron between the D.1 and D.9 versus 287 between D.1 and D.9. So XR nozzle, flat fan nozzle was still a little bit better, not by too much. All right, I said a 200 micron didn't look too bad until you see the others. When we spray with 300 micron setting, see how the trend start to look like. It's becoming a little bit of everything. D.1 is 162, D.9 significantly increased. This is 528 versus 430 versus 440. All right, so it's almost increased 88 micron. And then the D.9 minus D.1 is 366 micron. That was bigger than 319. So this means the range of the droplets was wider, you know, and I use a wider range of droplets to deliver 80% of my spray volume. At a 400 micron, the red line was really ugly. You know, it was really ugly. You don't see a pattern anymore. It was just all over the place. So D.9 minus D.1 was 451. All right. The most ugly one was this one. All right. Look at the line right here. It's just, you know, it's just ridiculous. Just ridiculous. So the D.9 minus D.1 is 498, you know, so this is unacceptable, you know. All right, I put the 2, 3, 4, 500 micron here, you know, so you can see the width of the red line, you know, so you can the D.9 minus D.1. So the number kept on increasing, you know. So using a almost 500 micrometer to spray 80% of tank volume, that's just crazy. You know, that's too wide of range. So this is why in my spray trial, I pretty much never used 400 to 500 micrometer, you know, in this case. All right. So somebody was asking, using a 110.05 to replicate drip as it is so much smaller, what a commercial ground would run? Well, the XR nozzle, the way we use it is kind of different than the ground rig. Is way smaller, you know, because we don't have time to pull a ground rig and actually compare it to the ground rig. So this just to give you some ideas of how does it compare to the traditional flat fan nozzle we typically use, you know. And also to demonstrate a point that a hydraulic nozzle probably will do a better job in terms of the uniformity of what we actually spraying, versus this 500 micrometer range we deliver most of our chemical with. All right, looking at the data, or looking at more data, we have water, 2 GPa, and a 300 micrometer. This is our baseline treatment. And this treatment is the same for Intact Pro, Rain, and Ultralock, So these three are the same in terms of value, for all three graphs. So this is why I put a red line across. So if the bar is higher than this, that means the VMD, the median droplet size is bigger. If the bar is lower, that means the VMD is the droplet size smaller. All right. As you can see, with the increase of DRA rate, we saw a little bit response from Intact Pro, but not a lot. Rain, not really. Ultralock, not really. It didn't change VMD that much until we changed the setting to 500 micron, and that changed VMD in a hurry. All right. So because that's determined by the equipment. So the conclusion we get here is the increasing rate with our DRA did not affect the VMD as significant as we would expect. And then let's look at DV10. Remember, DV10 is 10% of your spray volume delivered by very, very small droplets. All right, so this portion of your spray volume contributes to driftable fines, and that will be a problem, right? So we want to minimize this portion in the pie chart, but DV10 is the cutoff line. So we want to increase the DV10, which means you increase the droplet size across the board. So the very, very small droplets, the portion of that is reduced. So we want to have higher DV10 in this case to reduce the drift. Typical industry standard is we want to see DV10 above 150 because anything below 150 is considered driftable, So the higher we go, the better. Theoretically, not always true in reality, how we reduce drift. Looking at the Intact Pro, Rain, and Ultralock, we saw Intact Pro seems to be a little bit more effective in terms of increasing the DV10, which means reducing the drift potential. However, it's more of a rate response. Highest rate seems to work better than a lower rate. These two higher rate works better than a lower rate. And also in this case, 1% of Ultralock was better than this. 0.25% Ultralock actually decreased the DV10, create a little bit more driftable fine. All right, some DRA actually would create a little bit more of fine droplets. This happens in reality. All right, percentage coverage. So this is an important one because ultimately speaking, we want to increase percentage coverage without losing too many hits. Your standard is the same across the board for all three bar graphs. This one is about 1.75. That's water, 2 GPa, 300 micron. All the other one are sprayed with 300 micron except for the last bar. All right. So we saw 3 treatments from Intact Pro, 3 treatments from Rain. All 3 rates of Rain and Intact Pro significantly increased the deposition or percentage coverage. And also for Ultralock, we saw a little bit increase, but not too much. This is not going to be statistically different. We don't have time to run stats. Otherwise, I would have put the mean separation, the letters up here. This wouldn't be statistically different. All right, so Ultralock didn't have that much effect on the percentage coverage. But the interesting thing is when we spray 3 GPa and 500 micron, this one, full rate of DRA, 3 GPa, 5 micron, this one and this one, all 3 of this belong to that total disaster category, the total failure we saw in the first of the presentation. All right, the total failure don't look too bad on paper in terms of data, so don't get tricked by it. This one is interesting. Full rate Ultralock 3 GPa at 300 micron. it actually had almost the highest coverage, over 3.5% across all treatments. So this one is interesting. Pay attention to this one. All right, number of hits. We do want to keep the number of hits because I have a gut feeling, a fairly strong gut feeling that the efficacy you see in the field is gonna have a fairly high correlation to the percentage of hits. All right, if you lose too many hits, there's no way you can properly deliver a chemical. Think about many smaller droplets cover the paper thoroughly versus a 3 raindrop size or even like a dime size of the hits, which one gets you better efficacy. We don't want to lose too many hits, and we do have 4 treatment. 1, 2, and 3, and 4 get us above the red line. Remember, red line is the water, 2 GPa to 300 micron, that's the baseline. We do have 3 treatments get us similar or even better hits versus the check, versus the water check. This one, 1%, 3 GPa, 300 micron was one of it. All right, that makes me happy. All right. And also 3 disaster or 3 failure treatment. 1, 2, 3, full rate of DRA, 3 GPa, biggest droplets. You see how many hits you lose versus the check. All right. This one, this looks like 460, 470, something like that, versus 200. You lose over 50% of the hits because of the DRA you put in a tank and a 500 micron. And this is why the guys streak the field. You don't have enough hits to do the job. Your droplets are way too big and they're very ununiform, And also, if you look at this treatment, Ultralock 1% is 3 GPa, 300 micron. It also had the highest percent of coverage. So high percent of coverage, good. High percent of hits, good. So this will be my next target in the field trial. We haven't moved on to that part yet. But this is why you kind of have to run your own processing and all testing to understand what you're really doing in the field. All right. So this shows you the hits number for card. All right. 466 is the baseline. And we do have some higher number. This one, like quarter rate of Ultralock with 2 GPa had more hits. And this one, 3 GPa, full rate Ultralock also had higher hits. All right. Yes, the disaster happened with 500 micron most of the time. I think somebody was asking for that. All right, seeing is believing. So let's see all the papers we scanned to be able to tell how to prevent disaster from happening again. 2 GPa, 300 micron setting, it looks like this. It looks like this. Not too terrible. I mean, not great, but not too terrible, in my opinion. You still got big hits and small hits happening at the same time. Ultralock with low rate, 2 GPa, 300 micron, looks fairly similar to the water. Some of the cars may have a little fewer hits. That one looks good to me. And then Ultralock with medium rate at a 300 micron start to get ugly. Look at the big drops, big droplets. These are getting a little too big, and I'm losing hits for sure. There's not enough hits on that car to guarantee the efficacy. And then full rate of Ultralock, 2 GPa, 300 micron. The droplet size seems to get even bigger, and the number of hits are getting even smaller. I don't see many hits anymore versus the baseline. This is a baseline. This is a baseline. So I'm losing hits as the rate goes up. And then this is the failure. This is the failure. Intact Pro, highest rate, 3 GPa, 500 micron. You get a lot of raindrops. Those raindrops will not drift. They totally will not. But you're not going to get a lot of efficacy out of them because they're just too big. And then the failure times 2, rain, highest rate, 3 GPa, 500 micron. All right, how do you feel when you see all of those in your field testing? Now, I hope the South Africa guy have done this before he sprayed all his commercial fields. This is the worst one, man. Highest rate Ultralock, 3 GPa, 500 microns. So this is beyond ugly. Look at this big thing, big fancy thing in the middle. This is bigger than a soybean, probably, soybean seeds, even though your coverage don't look too bad, but you got some of those stuff on your paper. I mean, how do you feel about it? It's not going to be good, right? So if you all do testing, this is sort of things you're looking for, not just the coverage. So this big hit will get you a good coverage too, if you only care about data, but data doesn't tell you all of it, that percentage coverage. You also have to look at the number of hits at the same time. Don't only focus on one category and neglect all the other. That's almost like focusing on one tree branch and forget about the whole tree. All right, I said a 1% ultralock with 3 GPA at a 300 micron looks promising, so this is what I mean, all right? It still has some bigger droplets that I don't like, but I can live with those. I can live with smaller one. And then look at the hits number on this. It don't look too bad, all right? And also the data shows us that hits looks good for this treatment. Percentage coverage looks good. And also look at the DB10. The DB10 reached 200 micron, which means this one will also get you some drift protection at the same time. Not a drift eradication, that's impossible. All right, you get some drift protection because DB10 gets up to 200 micron. So that makes me feel better than this, all right? So this is why I said this last one looks more promising, Even though you put the same amount of DRA in the tank, you're spraying the same GPA, but at a touch of button, actually slide of a bar, 300 micron versus 500 micron. That's how much difference your finger can create if you have no idea what you're doing. One means total failure. The other one probably means pretty good, So hope this is something that people learned from this part of the training. Leaving off talk too much again. All right, I'll try to hurry up. Backpack data. All right, I know backpack is not the main focus of the training today, but many of y'all use fly fan nozzle. All right, so with fly fan nozzle, what happens if you add half rate of that ultralock versus 1%? We sort of see the same thing. Lower rate seems to be doing better in terms of the percentage coverage. And look at the VMD also increase versus water. Higher rate, not so much. It seems that we have a plateau around this 0.5%. And sorry for always going back and forth. I knew this would happen. All right. If you look at the hits data, all right, the lower rate of ultralock, the lower rate of Intact Pro, the lower rate of the rain, all showed a good number of hits. And also they all showed a good percentage of coverage, in this case. So that kind of make me think the importance of rate testing. Probably before you adopt a DRA, you may want to run some testing yourself to test at least 3 different rates, similar to what I did, kind of figure out which one works the best. It's likely that lower rate may actually be your choice. That would be the best candidate. You get increased deposition, and also you don't have a lot of the droplet loss, Also, I want to mention that all these treatments were sprayed with a fairly calm wind speed. I know you guys should be able to see this. The highest wind we measured was 6.1 mile per hour. Now we have a few treatments sprayed by 1 mile per hour wind, 1.9 and 1.8 mile per hour wind. So we didn't spray in a really windy condition. We try to avoid it, 2.5 mile per hour wind, you barely feel nothing, So there's not much wind. It's in a real calm condition. And then, yes, we do have seen a few treatments significantly increase the deposition. All right, so more than just one. Of course, the 3 GPA increased deposition, that's more water that you put in the tank. But this also answers the question I throw out in the first place. I understand the value using the windy condition, but in calm condition, do I get benefit? The data says yes. It's not Steve Lee says that, it's the data says that, And also, on flat fan nozzle using backpack, these see the coverage increase with half rate ultralock by volume. This will spray in 3 mile per hour wind, or maybe not even 3 mile per hour yesterday afternoon. So you see that deposition increase as well. So this is a talking point I want you all to remember. you only care about drift reducing agent. You know, that's what we call this type of chemical, DRA, or drift reduction agent. It comes with a second half of the name, which is deposition aid. A lot of time we forget about deposition aid. All right. I hope the data here make you realize deposition aid doesn't have to happen when it's windy. You know, when you don't have a lot of wind, you use the right amount of product, you can deposit more canopy, deposit more chemical onto the canopy of your crop that you're spraying. So the deposition aid is important. And also to reduce drift, you probably have to sacrifice deposition aid part a little bit. These two part of the names don't like each other that much. You know, if you want to get bigger droplets, most likely you're going to reduce the hits at the same time, and it may have a detrimental effect on your deposition if your droplet size gets too big. All right, looking at the 15 GPA from XR nozzle. This is what 15 GPA gets you. All right, so you would hope 2 GPA will be like this all day long. I mean, I wish that could be the case, but 7.5 times more water definitely gets you more coverage. Look at the number of coverage. It's in the range of 20 to 40. For the drone, for 2 GPA, it's usually about 1.5 to 2% coverage. People asked the question before, hey, is this 1.5 or 2% coverage going to kill the pest? I say, yeah, we kill a lot of stuff, you know, and it's working. It don't work all the time, but percent of coverage don't always mean the higher the better. All right. If this means higher the better, every single car should be totally blue. You know, you're basically power washing your plants. Hopefully you wash the insects, the disease, and aphids off. That's not going to be the goal. You're delivering chemical, all right, to the target. See, water only, you see a lot of fine droplets. Every single droplet looks like a ping pong ball when it hit the paper. And then if you use a DRA, they start to get bigger. Look at that hit right there. So what happened here, my guess is half rate of ultralock decreased the surface tension. So instead of every droplet shoots out like a ping pong ball, sorry, let me go back to this. Instead of every droplet droplets go out as a ping pong ball and make a very distinct hit on the paper, DRA was able to reduce surface tension. So what it makes is, you know, what happens is it makes the water behave more like mud, you know, like slurry or like slime. You know, my son a couple of years ago really liked slime, and those slime, you know, when it pour out of the bottle, if you hit on the wall real hard, sometimes the whole thing can stick to the wall. And that's probably what's happened here. You know, surface tension is decreased, and also the viscosity may be slightly increased as well, so it sticks to the leaf a little better. And that's the only reason why you can get a spot or mark look like this. You know, a droplet hit a mark. All right, I may or may not be correct, but the pattern does look better than this. And also why this happened, I don't really know. You know, this is 1% ultralock versus 0.5%. 0.5% looks a lot better than 1%. I checked the rate of what we sprayed yesterday, and then it was fine. You know, we didn't mess up, but my student didn't. So why the 1% show the lower deposition or coverage? No idea. This is another example to tell you, even with traditional hydraulic flat fan nozzle, you still need to test your rate because not all rates are made equal. You know, if 0.5% works, that's better because that saves you 50% of the DRA cost. All right, that'll tell us a bunch of things. Droplet size gradually worsens as your target droplet size on the remote control increase. All right, think about 200, 300, 400, 500 micron. The 500 micron was that red line was pretty flat across the whole spectrum, you know, and that is no good. And then 200 micron setting is likely going to give you best uniformity. Sorry, this is a typing error. So 200 micron is going to give you the best uniformity, but sorry, I deleted this best, you know, this is a typo. But drift potential increase significantly as well. All right, because you are creating more small droplets. It shifts that whole peak to the left, to the smaller side, you know. So DB10 will be smaller as well. All right. So deposition can be increased in calm condition by multiple DRA treatment tested. We saw the data. All right. So somebody tell you don't need the DRA in 3, 4, 5 mile per hour wind. That is not correct, or the data doesn't agree with that. We also saw the lower DRA seems to be favored to increase deposition and maintain high number of hits. Those lower rate may not always reduce your drift risk. The DB10 may not increase by too much, but it does help the deposition part if you increase about deposition part of the function. So if you run your own testing, probably start with lower rate first, and then compare to medium and high. Also, I feel like it's going to be hard to balance drift control and deposition at the same time. Higher rate of DRA frequently leads to reduced droplet hits. Think about those soybean or even dime, nickel size of the droplet hits on the paper. They're just ugly. All right. 3 GPA, 300 micron, 1% ultralox looks promising for future field trials. I think this one gets me a good balance of DB10, which is increased to 200 micron, and that's good. That's good. Percentage coverage, and also a didn't lose number of hits, actually increase the number of hits. And then the DRA type and the rate suitable for hydraulic flat fan nozzle is likely going to be different than Roto atomizer. So if you spray with nozzle drone, with flat fan nozzle drone, your rate for those drones is likely going to be different than the T20P, T40, P100 Pro, this type of drone with Roto atomizer. All right. And also we're testing more of 3 GPA, 300 micron, and the highest rate of interlock and rain down the road. Hopefully more data to come. And also shed some love for horticulture folks. Smaller droplets is what you need for horticulture crop spraying because the canopy is so thick. Some of the testing even go below 100 micron. All right, so this was sprayed by 100 micron. It looks good. We tried a 300 micron. I can't find a picture. I barely have hits at the bottom of the leaves. All right, so that's what small droplets can do for you if you need them to zigzag through the canopy and hit the bottom of the leaf. This is a slide from Ag from Brianna Layfield. Appreciate her for sending me this. They run a test of lower, middle, and higher canopy of the grapes. This is in a California vineyard. All right. You can see the deposition at upper, middle, and lower canopy when she used 150 micron versus 80. All right. There's no doubt 80 is a better choice versus 150 if you can control the drift. So don't spray when it's real windy. 80 microns real small. VMD was small, DB10 is real small, and also slow it down. Use your propeller downdraft to blow the mist into the canopy will be the best. All right. And also some operator asked me, how do you get data? We can buy paper, but we can't just eyeball it all the time. Or this is what I use to generate all the graphs you have seen, last so many slides. It's called SprayX. It's from a company in Brazil. They're legitimate. They're a legitimate company. I bought 2 scanners from them, and a bunch of us use their stuff. So basically, it's a portable scanner. You scan your 1x3 water sensor paper twice. Scan both sides, scan one side, take it out, flip it, and scan the other side, and then you'll get all the nice data on your phone in your iPhone or Android phone. So it's quite easy to use. And at the same time, there are other options as well. Drift management, not drift management, sorry. The drop flight is another one. You can scan the car with your iPhone. I know this app, I have not used it, so I cannot guarantee how accurate it is. But as a relative comparison, if you use the same app to scan a bunch of different cars, it's probably gonna work. And also the famous Swath gobbler. This one gets you the continuous spray scan capability. If you're interested in Swath testing, this probably will be the best because you can fly a paper, receive paper 100 foot, 150 foot, and all of those. Swath gobbler doesn't get you DB10, VMD, and all of those. And I see why, because there is no way we can use this type of paper to accurately quantify droplet size versus laser diffraction system. But so far, there's also no way for us to use any type of laser equipment to properly measure the droplet size coming out of the Roto atomizer T40 either. We want to measure this before the droplet hits any target. After it hits a target, it kind of make a smear, and the size of it, the spreading factor determines a lot of things. So these are the options we have to do these type analysis. And then show you a few real world cases, and then I'll be done hopefully in 10 minutes. I know I probably talk a little too much again. Tar spot, most of y'all know what it is. Versus, that's non-treated check, non-treated plants. Versus sprayed by Ultima fungicide full rate with ½ ounce per acre of justified DRA. 2 GPA T40 parameter use is here. I appreciate Tyler Fleck for sharing the images with me. These were the best picture I've seen so far of efficacy on corn, against tar spot. You still see a few disease lesion, but this is nothing. This is really good efficacy. And also you can see the untreated check strip, which started to die off the quickest. All right, we collected a lot of these stuff in the field. We spray fluorescent dye, and also it hit the water sensor paper. This one was sprayed by airplane using the hydraulic fly fan nozzle. This one was sprayed rotary atomizer, all right, T40, 2 GPA. You can tell the spectrum issue that I talk about. Very wide spectrum that we used to spray with T40. This is why you see small hits versus big droplets, versus the variation of the droplet size sprayed by the airplane. Very uniform. So if somebody asked me my thoughts about Roto atomizer, I said it's good, but it's definitely pretty far away from being perfect. One day, if some company make a Roto atomizer or give me a spray pattern look like this, I'm gonna be using it all day long. This is better, more uniformity. All right, we put a DRA in the tank with and without, with and without DRA. So this is without DRA, just water and fluorescent dye. This is water, fluorescent dye, and a drift agent. Because the deposition aid, you see the color getting darker. So the color come from here, come from the mitocards. We wash the plastic mitocards with no amount of water. And then if the dye concentration is higher on the mitocards, the color in this vial is darker. So you can visually see more dye was sprayed on ear leaf. Each vial means each card from each leaf, so that's how many leaves we sample from that tree. Looking at the percentage coverage from the water sensor paper on ear leaf, T40 2 GPA on the left, T40 2 GPA on the left, T30 2 GPA, T30 GPA, that's the second bar. All right, the last two bars are T40 flew east and west, perpendicular to the crop row, and also the airplane. Those 4 bars look pretty much similar. There's no statistical difference. What creates statistical difference is the stuff in the middle. Either T40 spray with 3 GPA, or you use a water, you use a deposition aid, or DRA in this case. This is how you increase deposition here. All right, visualize what I talk about. Without a DRA, this is how many hits we saw. With a DRA at a Columbia side, significantly increased it. This is at the other side. The other side, I had a better coverage with T40 at 2 GPA without a DRA. But with the experimental DRA, I think I still get a few more hits. All right. That's a dye deposition data. Again, T40 2 GPA, T40 3 GPA, for DRA treatment. At the Blakely, Georgia side, when we spray at the tassel stage, we saw significant higher dye deposition on the ear leaf versus the check. At the Columbia side, we didn't see that. We didn't see the deposition increase because of 3 GPA and the other stuff. But the reason is we call no wind when T40 was spraying. So this is the best case scenario for T40 at 2 GPA versus probably the worst case scenario, 12, 14 miles per hour with Intact Pro and Experiment DRA. So even with a bunch of wind, a high wind gust, we deposit similar amount of dye on the ear leaf versus T40 spraying at no wind. Burn down. I did a lot of burn down type of work, not just because I'm a herbicide specialist, because I'm also using burn down to show the uniformity of my spray. This is the day of application and 12, 13 days after we spray. Using 2 GPA, using widest swaths, T40 allow you to do probably 32 feet. All right, I don't recommend you do this on the at home, but at the perfect condition, really good droplet size, about 200 micron, you can cause a lot of damage in the field. But using the same configuration and settings in a really windy setting, you get a lot of streaks, or if you stretch the swaths too wide. All right. So this is what I mean by utilizing the weeds, the cover crop, to show my deposition uniformity. Because if I streak herbicides, I'm going to streak fungicide, insecticide, anything I spray, you're going to have this overlapping problem in between the passes. It doesn't matter what you spray because herbicide will visualize where you missed. So looking at a herbicide streaking issue, which is also a big sticking point, a lot of crop dusters are laughing at the drone guys if you streak a field. We use the T20P to spray really thick winter weeds. These are over my knee to my pocket high, all right? Average wind speed is 1 to 4 miles per hour. And we spray with 300 micron setting. This is the setting we use, the top speed. Also, only spray 2 GPA. That's a suicide mission. There's no way 2 GPA can kill everything here. This is just a test. So throw out a disclaimer here. 300 micron setting, the day we spray T20P. And then we also measure the deposition on the ground at the same time. All right, deposition track, there's a how thick we're spraying. So I step in it, I couldn't see my foot. Usually this is the perfect case scenario to show streaking. All right, chemical was Roundup, Sharpen, and high concentration of the crop oil, Destiny HC. That's a fancy crop oil. So no DRA, that means just straight herbicide with 1% interlock, which is all emulsion based of the DRA, different than ultralock. Ultralock's polymer based. So deposition for interlock looks very similar to no DRA, maybe slightly more uniform. But 1% ultralock definitely reduce the small fines and reduce the droplet hits. Bigger droplets, less hits versus no DRA. So that could carry a detrimental effect because I don't have enough hits and some big droplets that I don't particularly like. All right. So looking at data, no DRA, interlock, and ultralock. VMD got increased significantly by ultralock. And also look at the hits per card. All right. Ultralock has the fewest number of hits. 1,200 without ultralock, a little bit over 600 with ultralock. So I lose almost 50% of the hits, which is not good. Interlock also lose some of the hits, but not that dramatically. Percentage coverage, we saw a trend of reduction, but not statistically different. Also, the other thing I want to say is no DRA sprayed no DRA means the chemical alone. Using the same parameters that I spray the water. VMD of water using same parameter, same GPA, same drone was 342. And then this treatment, Roundup, Sharpen, COC without the DRA, this treatment reduced the VMD almost by 100 micron. All right. So this is something I want you to keep in mind. You spray water, maybe droplet looks good. You spray a real chemical, droplet size could either go higher or it could even go lower. That's the VMD. VMD dropped almost 100 micron in this case. Everything was the same, when we sprayed. And also with 1% ultralock in the tank, VMD of ultralock only decreased to 30% versus 1% of ultralock in water. All right. So with DRA in the tank, the same chemical mix, this chemical mix did not decrease the VMD that much versus water alone. All right. So this one actually will prevent a little bit of drift for us. DV10, we saw an increase of DV10, which means a little better drift control, not by too much, but you can see the difference, a little over 120 to almost 160. All right, how does efficacy look like? Well, interlock block is on the east side. Chemical check is on the west side of this section, of this eastern section. ultralock sits down here. This is about 1.5 to 2 acre block. All right. So red indicates lush green that I didn't kill. All right. So red is bad. Red means your green streaks. Ultralock 1%, no doubt, give me the worst streaking problem. All right. Because I lost too many hits. I lost too many hits. Interlock, this is non-treaty check. This is non-treaty check. Interlock, even though interlock lost a little bit hits, but streaking versus non-treaty check was a little bit reduced. All right. This was interesting because it didn't increase coverage. Coverage was the same. I lost hits because interlock. All right. Hits was lower than without interlock. And also at the same time, DV10 was the same. Droplet spectrum was the same. The only thing was the variation of VMD was a little lower with interlock. This was the only thing I saw. But for some reason, maybe it's because interlock uniformed the droplets a little bit better, I saw lower streaking. So measured NDVI out of the 3 blocks. No chemical was 0.5. With chemical, with this 2 drift agent chemical, this is a chemical check, my bad. With interlock and ultralock, the NDVI was a little higher with 1% ultralock, with 0.524 ultralock. The NDVI was a little higher. Interlock was slightly lower, almost the same as chemical check. So worse streaking was created because I lost hits. All right. We ran another testing, and this was a 3 different treatment. This one didn't have DRA. We used Roundup, Sharpen, and COC again, same mix as the previous example. This one got ultralock 1%. This one got ultralock 0.5%. All right, 1% and 0.5%. The only difference is I learned my lesson. I reduced the droplet size. So the Roto atomizer, the disc was spinning faster in this case. So when the disc spinning faster, and then it's created very interesting results. And also I sprayed in relatively calm condition, only up to 6 mph wind. So it's not a lot of wind, I would say. Some gusts might be strong, but overall it wasn't too terrible. Wind speed came from south-southwest. All right. So we'll only look at deposition data inside the plots. All right, at the 200 micron setting, the previous field example was a 300 micron setting. We saw worse streaking with 1% ultralock. With 200 micron setting at 2 different rate of ultralock, 1% still don't look super good, even at the 200 micron setting versus without ultralock at all. However, this lower rate ultralock at a faster disc spinning speed was interesting, especially this one is very satisfying. More hits and very uniform as well. So my student told me half rate ultralock was looking pretty good in the field. So I was hoping better results. So looking at the VMD and number of hits, all right, VMD slightly increased because ultralock and half rate and 1% rate, and also the hits decreased as expected. 1% decrease your hits compared to without it. All right, so I don't want to lose too many hits, so I can live with this. This is lower, but not statistically lower. So as a result of increased VMD and a little bit loss of hits, actually the percentage coverage was numerically higher. This is not statistically higher, but it's numerically higher for half rate ultralock versus 1% ultralock. 1% ultralock, I lost quite a bit of coverage, So 4% of coverage at 2 GPA is superb. That's very hard to do, in most of the testing. Most of my testing fall into 1.5 to 2.5 range. So this is a fairly high coverage. And also DV10 was increased by 0.5% as well. Not by much, but droplet size increased slightly. Okay. Also the variation, CV measures variation. Variation was decreased because of this lower rate of the ultralock. So this is whole testing looks like. This is a chemical check without any ultralock. This is ultralock by 1%. You can see quite a bit of green stuff in the field versus without ultralock. And then this ultralock at 0.5% looks pretty good. I don't see a lot of streaking. And then I think the reason is because I didn't lose a lot of hits. VMD slightly increased, but still in a very comfortable range. 250 is a very, very good range, for efficacy. And then I have a slightly higher coverage. And it's actually almost the highest I've seen at 2 GPA. And then uniformity was pretty good with VMD. So I saw less streak. So I hope this picture worth all the time you sitting here listening, me doing all the preaching, and I'm getting a little tired as well, talking for so long. So hope this will give you some thoughts when you run your own test. Not always the higher rate, the better. Lower rate might give you a better shot in some of these cases. It may not help you reduce the drift, but it probably can make your spray a little bit more uniform and reduce some of this issue and potentially increase your deposition or percentage coverage. All right, NDVI 0.5%, 1%, and chemical check. Chemical check was 0.358. 0.1% was almost the same, and then 0.5% was a little lower. All right, so the NDVI confirmed our observation. So it was a little better kill. Lower NDVI means more dead stuff out there. All right, so this might be the last slide I'll show, and then I'll be done with it. So thoughts at this moment about DRA. The importance of DRA rate study for future labels. This one is warranted. Not always the higher the better. And also, there's no one rate fits all type of situation. You need to fine tune the DRA rate for each case scenario. Also, we need to address the special use case because in forestry application, in high altitude operation, you spray pasture 20, 30 feet above the ground because obstacle, you may need a large VMD to reduce evaporation. In that case, we want to increase the droplet size. And also, if you spray auxin herbicides, maybe a fewer hits do not significantly reduce efficacy. So some of those not so good water-sensitive paper may actually work out pretty well for that situation. So one man's garbage may be the other man's asset. Just depends on what your goal is. All right. So some of those auxin herbicide can be sprayed with ultra coarse droplet and still get fairly good efficacy. And then more testing on guar-based formulation because it has a really low use rate and show promising results. I don't have enough data, but I want to test more on the natural gum, guar gum formulation. Roto atomizer speed and DRA interaction. Roto atomizer speed, the spinning speed, is still another thing I don't fully understand. But we know for sure at a slower speed, which means it creates bigger droplets, the droplet spectrum looks pretty ugly, Hopefully this will be improved with future development. And also, is pattern collapse still a thing for Roto atomizer? I don't believe so, but I haven't really put a 3-4% of DRA in the tank yet. This is a big problem for a hydraulic nozzle. If you use too much DRA, you won't have the fan pattern anymore. This stuff is dripping because the viscosity in the tank is so thick. And also, I want to create an example using DRA at a proper setting to reduce downwind drift and reduce downwind buffer. I hope I could be able to do it next year. All right, how do you run your own testing? I mean, you saw how I did it. You can basically copy and paste and see which one works the best. But this is a quick procedure if you want to run your own testing. You probably have to if you want to grow your business, improve your method. Nobody can do this for you if you don't want to spend the time to do it. If the South African guy did his testing, he probably wouldn't create all the green streaks in sugarcane in the first place, So not as hard as you think, but you do have to spend time and maybe some effort or money on it, and kind of go from there. I will show one last thing and then I'll be done because some people ask me about this. Okay. Do we need adjuvants in the tank to make it look better? The answer is yes. All right. I've spent quite a time working on streaking or the uniformity of how we spray. And the whole goal is to increase uniformity, particularly in between your passes. All right, looking at this example, I forgot which one we spray. We may spray this with T30. This was before T40 days. All right, T30 sprayed. This long strip here was Roundup Power Max and 240 together. It antagonized the crap out of the drone. And I dug this thing out by hand. So don't try to do it, especially the K salt of the Roundup antagonized even worse than IPA. All right, somehow we made it work and it just clogged up. All right, Roundup Power Max 240 on really thick cover crop, rye, clover, tillage, radish, this is waist high, you know, this is a really, really thick cover crop. So you see really bad streaking. Red indicates lush green where I didn't spray. You can see all the red streaks or green streaks in the middle of the passes. You can even count how many passes I sprayed. All right, so the thicker vegetation you spray, the more likely it's gonna streak. All right, after using a better chemical, you gotta make sure your chemical has the highest efficacy against your pest. That's always pest control number one. Roundup Power Max with Reviton. Reviton is a burn down herbicide, really good on clover and particularly on radish. I see more blue color. Blue represents dead materials. All right, and you can also see I sprayed a 32-ounce Liberty. I created beautiful streaks, very straight, very long, beautiful streaks. You know, where I didn't kill, the overlap was just bad. However, this one is interesting. Roundup Power Max with Reviton with 1% of methylated seed oil. I forgot which one I used. I think it was a nutrient Loveland product. 1% methylated seed oil. This plot was noticeably more dead than this one. Even you can tell from the color. I don't have an NDVI number here, but blue means dead material. The bluer it gets means the more dead it is, which is good. All right, the least amount of streaking in here at the same time. So somebody asked, do we want adjuvant in there? Of course, you know, especially you're dealing with a suicide mission like this. Do I recommend people spray that with 2 GPA? Oh, hell no. It's just a test, you know. I have to go crazy, so I have something nice to tell you. But if you really spray in tough condition, adjuvants will be your friend, you know. Also, seeing is believing. That's the non-treaty check. Really, really thick clover, rye, and radish in there. 240 and Power Max. It didn't look too well on the broadleaf species versus Roundup Power Max, Reviton, and a 1% methylated seed oil. That's a way better improvement in terms of efficacy. If I spray 3 GPA, I probably could have killed this wild radish or tillage radish even better, but there's nothing green left in the plots. All right, last thing I want to tell you is when you read the label, a lot of time it shows like this. They don't tell you how much you need to spray until you get to 5 gallon or above. This is ultra-lock label. It goes by the GPA, and then the rate is different. And also for rains, for the DRA I tested, this is the Loveland rain DRA. It goes by the pressure. All right, different pressure require you to use a different amount of rain. Neither one of the two apply to your T40, T50, P100 Pro, whatever, or atomizer. Then how should I call for the rate to use? All right, most of the time, let's go by the volume. I like the Intech Pro a little better because it tells you the volume here, 0.125 to 0.375% by volume. All right, so convert it back to volume. Most of the time, you don't need more than 1% by volume. It's gonna do bad things for you. You know, actually, you saw my data. Lower rate may seem to work better if you just want to increase deposition, you know. So this is one thing I want to tell you. For some rookies, if they want to reduce the drift, they pick 10 ounces of ultra lock, you know, or the highest rate of rain and use on 2 GPA. You know, that 4 ounce of ultra lock is 1.56%. You know, 6 ounces is that's 2.2% by volume. That's way too much that you need. So this type of rate structure can be misleading as well. So if you don't really know what rate works for you, my general rule of thumb is 1% by volume, and it could always go lower. Then no more than that. Just try lower and see which one works better for you. You know, and also if this 0.25 to 0.5% by volume range proved to be effective, the cost per acre is very appealing than 1%, 1.56%, because that's a fraction of the cost versus that 1/3 of the cost. You know, this stuff is not cheap. So if you don't have to use a lot and still be able to increase deposition, I'm all for it. All right, last thing about my drone adjuvant daydream. You know, sometimes I do daydream, and then this may or may not even happen at the end, but these are all the characteristics we need in this type of application. So I just put everything all together at once. Yeah, this is way too long than I expected. Sorry, I added too much stuff in here. I don't know how many people left after the webinar. But at least I still have the 3 panelists here, which is great. All right,
I'm here, Steve. I think we still have 100 people on, so you did pretty good.
Okay, we still got 109 people. Wow, this is awesome. All right, so how about 5 minutes break, and then we'll come back and have the panelists to answer questions. We can go back to some of the questions people ask, and also talk about some of the specific questions regarding adjuvant and formulation. So yeah, about 5 minutes break, and we'll come back and resume the discussion.
And Steve, I've got a T40 and T50 here in the shop with me, and I've taken off the atomizers. So I know we had some questions about like atomizer just in general. If I can get my video on, I can actually show the atomizers themselves on these different drones. People can see what they look like on the inside.
Yeah, that would be really neat. You should be able to turn your video on. I don't think why not.
Well,
Yeah,
if you're the
yeah, because the host has stopped it.
This whole stop it. Oh my bad. So you won't be able to show a video, I guess.
Yeah, like whenever we go to click start video, it says you cannot start your video because the host has stopped it. So it's almost like we don't have permissions, basically.
Anyone has idea why this happened?
Could be like if you check in like host settings or something along those lines. Maybe like allow panelists to share videos, or I don't know.
Yeah, let's see. I haven't had this issue in the past. The panelists will be able to share the video just fine. Oh, I'll just make you host. How about that? I'll make you host. I'll make all 3 of you host.
There you go. It's all about workarounds in this industry, right?
Yeah. Oh, make a co-host. My bad. Make a whole co-host. I can't make a host because there's only one host. Make you co-host. Co-host. All right, Taylor, can you try again? Oh, I see Rick. Yeah, there we go.
Hey, cool.
All right, I'll stop sharing. Oh man, I apologize. This thing is just getting a little out of control at the end with my content. I wasn't planning to present this much, but it just keep adds up.
Well, more information is better than less information.
Yeah. All right, we can see you well, Taylor. We can see you well.
Cool. I can see you well too, Steve.
Good, good.
Have you had the 50 up yet?
No, we're planning to try it tomorrow and see how it goes. And I'm excited to spray 3 GPA using the exact same parameter as 2 GPA. And see how that goes.
Yeah.
Yeah, we're spraying ultra low volume at the moment, so it's beautiful.
Ultra low, like 1.1 or
1.
1. Yeah,
Like exactly 1. Technically we would do like 0.5, but I kind of messed up the oh, welcome home, ladies.
Honey, I'm home.
We're at our Airbnb right now, obviously. But yeah, normally we did a little trick with the to do it at 0.5 gallons per acre. I'm gonna actually move out here. Are you guys gonna be outside?
Yeah, we're gonna put this up.
All right, yeah, cool. I'll stay here. Never mind then. They're going back outside to get back to work. Yeah, we've been doing, we did a little trickery, which I kind of can't talk about right now because it's industry secret at this point, and it's kind of given me a competitive edge right now. But let's just say it involved using different nozzles, tweaking the calibration, and then changing to different nozzles and manually calibrating to achieve the droplet sizes and everything that we want to do. And it worked out good. And yeah, hold on a second. Let me.
All right, Taylor, I guess without taking too long, do you want to start?
Yeah, sure.
Yeah.
So I was just gonna, I know there were some questions on what nozzles like the T40 or T20P had versus T40, and then there's T50 coming out. Two very, very quickly. So I've got T40 here behind me, and these are, so if you guys aren't familiar, these are the nozzles, rotary atomizers, I should say. There's two of them, one here and then one over there. These are the same that are on the T20P. So on Steve's testing, this is what they would have been here, basically coming out of the pump on the bottom of the tank, up through the arms, and then out to the rotary atomizer. I've got a couple of them over here, so you guys can actually see what the inside looks like, the guts look like. This is what comes on the T40 and the T20P kind of out of the box. And they call it a double atomization disc or nozzle. Basically, you've got two discs or two places for it to atomize. Here's the first, so basically droplets are water's gonna hit here. Your water's gonna hit around this ring here, which is actually a gasket to cut off the flow. And then it's gonna drop down in here. And as it spins basically through these channels and through these grooves here, and then it's gonna hit this outside ring right here. You can see there's kind of some grooves all along here. And that's the second atomization versus a single atomization, which is like what XAG uses on theirs. And then you can put this on T40, T20P. And obviously there is no outer shell to this. We've got some T50s that we've been testing here over the past just few weeks, really, some wheat fungicide. This is the disc that comes on it, the nozzle that comes on it. Looks very similar to T40, obviously. There are a couple of differences, though, which could affect, possibly some of the shear or some of the droplet spectrum. So you see there's no gas. Here's the inside of it. There's no gasket on the inside right there in the middle. There's actually a well right there in the middle versus T40 right there. That gasket is needed on the T40 to shut off the flow. It basically, goes up and down to shut the flow off with that gasket. T50 has a valve, electromagnetic valve, and that's what shuts off the flow, so they can actually take away that gasket, put a well there. And then the other difference here too is the height of our outer fins or knives, what I'm going to call those, they're taller. The inside's the same, but the height of the outside are a bit taller. And then of course the same thing with the outer disc as well, just a bit taller. So that's what the inside looks like of these atomizers.
Curious question for you there, Taylor. That change that they made there, is that for strictly an improvement standpoint, or is it to fix the notorious leaky nozzles on the T40?
Yeah, so notoriously leaky nozzles is first. The gasket was basically your valve, on the 40. And that's, I don't know if you guys can see this on the camera, but here is the single disc on the 40. And you can see how it just has a straight channel there to lock it in place, basically, versus the double disc, double atomizer has this like slant to it. That's basically to throw it down. So basically when you turn your spray system on the T40, it runs high RPM and it throws this down, opens up the channel. This basically, the gasket here, it rests against the bowl, and that's why it has to throw it down to open up that cavity, and then it locks it back up in place. So yes, that is to, first off, I can show you guys. The T50 is out here actually.
Didn't mean to call out your T40s there, but
You what?
didn't mean to call out your T40s, but you know.
No, we know that. We're not ashamed of leaky nozzles. Leaks
Right.
happen.
Mhm.
There's fixes to it, but this is the T50. Say hi, guys.
Hey, how's it going, guys?
This is the T50. That's the that valve, that electromagnetic valve. So that opens and closes on the inside. And so when the spray system is on, that closes. When it's off, or sorry, when it's on, it opens. When it's off, it closes and prevents all the dripping down there.
Gotcha.
That's good because Taylor, we have seen the dripping droplets on water sensor paper and the collection cards a lot of time in the past. Whether it's because the valve doesn't get shut off completely, it's still dripping, or it's too much of flow on top of that rotary atomizer is flooded. Either way is bad.
Yeah.
Yeah.
Yeah, I agree. And really, it was really just the main, the biggest problem was just land back on the trailer and their nozzles are just dripping. There's another on the T40. They've also got check valves inside of here, but those check valves aren't strong enough whenever you got head pressure, basically pushing down to the nozzles, especially with that single disc. So
Yeah.
I think, yeah.
I don't want to derail it too much here to talk about the T50, which I'm sure everybody is, but just real quick out of curiosity, between the two rotary atomizers, T40 versus T50, is there a significant actual improvement as far as, droplet sizes? I'm not talking about, how it's been leaking or anything like that, but as far as like, does it spread it further? Is it more consistent? Is there an actual improvement on that?
More information to come. It would have been nice to have these drones last fall, but we did not.
Fair enough.
Yeah, so more information to come on that.
Okay.
I don't think there will be a huge difference, honestly. I mean, the 50 and the 40 are essentially the same frame, motors, props, that design. So this is kind of like the one major change. Yeah.
Gotcha. Yeah, and like I said, just curious, but I'll put it back to Steve for however we want to do this.
Yeah. All right. Yeah, somebody was asking about if I use a dual atomizer or a single disc, a dual versus single. I use a dual. I just use whatever came with the drone. I didn't change to single because single tend to leak more than a dual. So that's what I use. All right. Back to the question I have for you guys. I actually thought about a really good one. I'm not sure if Fred is here or not. He's still muted.
I'm here.
Hey, good. Hey, good to see you. All right. All right. Thank you for joining us. I know it's getting a little late. And I totally blame myself. I owe you guys a lot of beer next time when you see me, because I always talk too much. Don't plan the time very well. So I actually thought about a really good one I want to ask you, since Taylor started to show the hardware. What do y'all think? Is it possible that we have some sort of tank agitation or circulation in future drone design? I know that's a hard one, and I didn't really send you this question earlier today, but what's your thoughts on that, to fight against the incompatibility problem?
Yeah, I mean, I don't know, Taylor wants to take this one. I'll start it off quick. I think it would be an awesome idea. Whether or not how easy it would be to accomplish without putting even more strain on your battery. I mean, possibly having even a standalone system that's like an auxiliary battery source instead of using your normal ones. I mean, there's many different ways from a hardware standpoint of how it could be done. And I would 100% love to have an intake agitator on the actual drones.
All right, Taylor and Fred.
Yeah, I think it would be great. When you start getting into some thicker material, it would really help just to keep it in suspension. It might open the door for dries, but I don't think with a lower volume that you'd really want to do it. But even if it was kind of similar to what they do with the sensor on the dry tank, something like that, just to swish it around, a little bit of extra movement would be good.
You look like you're really in the field. This is
Yeah,
not a pretty picture,
I was a
right?
little, it's been a busy day.
Oh, wow. Okay.
But
I appreciate
if I
it.
go down there, I lose signal, and if I move, then so I'm stuck in the
Thank you
field.
so much. Yeah. Yeah, thank you. Taylor?
Yeah, I mean, so, fungicides aren't too big of a deal. Maybe you're doing really low volumes, high concentrations could be herbicides. Obviously, we run into your problems. And so if we put together, we've run a couple of these. It's just like a 3D printed kind of a bracket, motor, external battery, and like a little impeller on the bottom. We just drill a hole in the top of the T40 tank and drop it down in there
Ooh.
and just plug it in. It does work. I mean, we don't use it very often, or we haven't really sent many of these out, I guess. I don't have many guys complaining about compatibility issues, spraying off a load every 5-6 minutes. But yeah, so you can do it.
Yeah, okay. All right, that's neat. I never seen that one before. All right.
I might, if you have compatibility issues, Steve, I might just send you one of these down and you can try it out.
Yeah. Cool. Yeah, I don't have a lot of that problem, but I know guys tend to put everything in the tank, spray 2 GPA, they'll have a lot of that issue, you know. And also somebody told me a lot of the tank incompatibility problem was caused by low spray water quality, you know, high pH, magnesium, calcium, iron, you know, or sweet tea color water that you have to use, you know, that contribute a lot of the efficacy and tank mixing issue. Um, any thoughts on that, or maybe you have seen that before?
No, I personally haven't. No, I mean, with water quality in general, the only time we had water quality concerns was the farmer supplied water was extremely brackish, for lack of a better word. Let's just say it had a lot of droppings in it, and it was literally just clogging our nozzles. So it wasn't necessarily actually causing, mixture compatibility. It was just the case of, the drone is coming back saying that it sprayed out 5 gallons and just did, an acre or whatever, and it lands and it's still got a full tank on there, even though it looked like it was still spraying. So that was the only issues really that we came for water quality. Past that, I mean, we've used spring water, pumped it literally right out of creeks, and I've never actually had any, mixing compatibility issues in that particular regard. No, not from water quality at least, but that's just my own experience.
Mhm. Taylor or Fred, go ahead.
Yeah, I'd second that. We put a strainer in on our fill line, so anything that we're pulling in gets screened once there, and then we have another one once we fill into our hot tank. So we have double screens just in case because of that. We've had that same issue. We mostly had that issue with the T30, even like small particles that may have been in the tank just clogged up the nozzles and
Yep.
just caused a bad day. You get all kinds of errors whenever you're not running the right gallons, and it looks like it's spraying. So what do? Do you go back over it or do you not? And yeah, so we put in 2 strainers and that seemed to help. But as far a lot of the water that we deal with is low pH. The biggest thing is probably high iron, but
Yeah.
a lot of guys are putting in like a request or some kind of water conditioner to help sequester some of that iron. That's typically, if we get into a Roundup product, we have to have it. But for fungicides and everything else, so we haven't had any issues.
Yeah, no main issues. I mean, yeah, when we're running, like with like the T30 or the old T20, with T-jet tips, then obviously the clogging with some of that really brackish water. But rotary atomizers and the impeller pumps seem to solve that problem. I know my thing on water quality would be what products are you applying, and efficacy of those products, that water, pH, whatnot. I know Alex Harrell talks about doing a lot of testing with products and different pHs and whatnot. That's probably more important. And it's actually feasible with drones. I know guys are with ground rigs who were put in like reverse osmosis systems and whatnot to get really, high quality water. Well, at 15, 20 gallon per acre, that gets pretty expensive.
Yeah,
But yeah, using a lot less volume through a drone, that's a little bit more feasible.
yeah. For those of guys don't know Alex Harrell, he is the top yielder of soybean in the world. 300 bushel was achieved last year on his farm, South Georgia. He also sprayed with a drone as well. He actually texted me earlier today that he flew T50 for the first time and liked what he saw. So yeah, I know he talked about even installing a reverse osmosis system, which is really expensive to generate the spray water. Because at 2 GPA we don't spray a lot of water, but he's the top of notch, I guess, for a reason. If he has that kind of idea. All right, what about water conditioner and defoamer? The things that we typically have to deal with. Is that quite common for you all to use?
Yeah, it's kind of situational. It probably depends more on the material, and a lot of different factors. Usually, we'll carry it, and if we see that we're foaming up, sure, we'll throw some in. But most of the time, a lot of the stuff that we do, especially, is like insecticides and things along those lines that don't really foam up. A lot of times we're running it neat anyway, so we don't even have to mix to begin with. So for us personally, we use it when we need it, but we don't just do it preemptively as part of the normal routine. It's just on a case by case basis for us.
Yeah.
Yeah, the DRA that we're using is a Loveland product, Compadre, and it's got a compatibility agent, and it also has a like a defoamer in it. So we've had good luck with that. Before that, we noticed two things. If you're running an automatic shutoff on fungicides, especially, you're going to see a lot more foam. So we swapped that out to more of a manual type or just a regular valve, and that helped with the foam quite a bit. But we try and manage it mostly because when we had a lot of foam using that automatic shutoff nozzle, it basically turned a T40 into a T30 from a capacity standpoint.
Yeah.
You'd fill that thing up and it would shut off, and there's only 7 gallon in there, and it's like, we just have to fill it all the way up, and we don't want to wait to fill it up, right? Because every second counts on the refill. So that's why we started running it on just about everything.
Yeah, that's true. Your 10.5 gallon tank turned to be 7 to 8 gallons. So top is just all full.
Right.
Yeah.
Yeah, herbicides seem to cause all the problems. So
Oh yeah, Liberty foams like crazy at 2 GPA. Roundup has that problem too. Some of the fungicide formulation are actually quite good for that 2-3 GPA. I think it was probably the best formulation I sprayed so far. Stuff like Probosor, Weltima. What was the other one I sprayed? It was also pretty good FMC product. I'm drawing a blank.
Miravis Ace.
Miravis Ace. That's awesome. Miravis Ace is awesome.
Yeah, that one, I just got that one last week. That was pretty fun. The Taylor, I'd be curious to see when you're running that Aquaneat, or if anybody's running that Aquaneat, you're running that at like a 5 gallon per acre rate. But I've had issues with that, and it's just that in a surfactant. It just, if you're not agitating that thing like crazy, it'll settle out in foam. But it seemed like if you up the rate just a little bit, like 5 1/4, 5 1/2, somewhere in there, it made a little bit better. But I don't know if anybody else has had any luck with Aquaneat, because that one's kind of thick stuff, and it foams up like crazy.
Yeah, we used it a few weeks ago, I think. And yeah, well, we didn't have any problems with it, but the tank it was in was a constant agitation. But as soon as it goes in, it's pretty much getting out. So we didn't have any. Honestly, we didn't even have any foaming problems with it or anything. But it was also a cocktail. There was probably, I think it was like 5 different chemicals were going in that. I'd have to check my logs, but so it's like, I mean, it's very possible that, the other stuff we're using was kind
Yeah.
of binding it all together. But yeah, I mean, we ran it a 5 gallon an acre and it worked. Let's just put it that way.
Yeah, I wonder about the they had us running Signet, which is their aquatic surfactant for cattails, and I'm wondering if that might have been the issue because it looked like it was fine in the tank, and then all of a sudden it just started settling out.
Mhm.
So I bet you all had experience that something may be looking fine in your hot tank because you have agitation, but you put it
Right.
in the drone tank and then bad thing happen.
Yeah, we actually for some of the thicker stuff, the internal fine mesh screen at the bottom of the T30 tank, we actually had to take it out because we were finding that it was actually separating the material. So it's sucking the water through, but it
Yep.
wasn't taking the actual particles. And then you'd have this nice big, little glob down towards the bottom there. And we actually kind of open it, we were spraying it on the ground and you can see it. It's just trying, the material was literally stuck to the side of the screen trying to go through. And yeah, so we ended up just taking it out. It pushes through the nozzles, no problem, but that fine screen just caused some problems. So we don't even run that thing anymore. We just, like Fred was mentioning, we switched to the double screening on the actual intakes and then going into the
Yeah.
drone.
Yeah.
And we learned our lesson after we got that nasty water in there and clogged everything all up. So I think that's probably the best way to combat a lot of those problems too, is take out the fine screen and screen your water first.
It'll do that to metribuzin too, in case you're wondering.
Gotcha.
That's
I
another
found
fun one
first
to do.
first thing I sprayed when I had my T30 was Roundup metribuzin out at our farm at home just to play around and see coverage wise because we had a cover crop and we wanted to see how the coverage looked. And yeah, we had that same issue. That fine screen inside the drone just caked it right around there. So we ended up yanking it out and we didn't put we haven't used metribuzin in the drone anymore.
Steve, Greg on the Q&A has got a couple of good questions here. So a couple on swath width, and asking about when you're testing swath width on flat ground versus on leaves on corn. Do you
Oh
see a
yeah.
difference?
Yeah. Okay, yeah, my bad. I completely forgot about Q&A box. We were having fun just talking.
One
to each
job,
other.
Steve. One job.
Yeah. I gotta share some love with folks still hanging with us. Still 81 people hanging with us. That's unbelievable,
Yeah.
All right, let's see. Do you see similar effective swap with between cars on flat ground versus cars put on leaving corn? And also do DRA affect swap with? All right, the first one, I have a better answer or better feeling about my answer than the second one. Second one, I just don't have a lot of data to answer your question. First one is effective swath with on flat ground versus inside a canopy is definitely different. All right, I don't have time to show you this, but if you talk to me after the training, I can share you 2 pictures. Very thick canopy like full-size corn at vegetated tassel stage, it's possible that your swath may be reduced some, because that canopy flat ground always give you, or thin canopy always give you the chances to reach the widest swath. All right, so it's the same reason that if I'm spraying with nothing on the ground versus I'm spraying this thick vegetation, try to kill it, how do you create a streaking issue? So canopy definitely has a effect on the effective swath width, we just need to create more data to show it. And also the other reason why I know effective swath width was affected is because on flat ground, the CV of your deposition, CV coefficient variation measures the variation of deposition. CV is definitely always lower when you test it on the ground, which means you spray more uniform versus the CV I collected from corn leaves. For example, ground deposition data CV, just talk about CV of percentage of coverage is usually around 40%. If I do really, really well, I do a super good job, maybe I can reduce down to 20, 30%. But that means higher GPA, narrower swath. In the corn canopy, CV is usually 80%, 60 to 80%. In rare cases, I can drop down to 40, but most of the time it's between 60 to 80. So that CV of percentage coverage on year leaf tells you which one is more uniform. And of course, your effective swath width, is going to be affected by all of these. So you have to reduce your swath width to increase your uniformity and reduce that CV. Follow-up question. On your failed streaky burn down, it looked like you were simply taking too wide of swath. Possibly, but swath is not part of the test. I'm keeping swath the same as 30 feet. So if I see something reduce the streaking, it's got to come from DRA. It's gone from the DRA that I used. So that answers your second part of the question.
I had a question on that, Steve, actually.
Yes.
Follow up there. I noticed on that picture of like the NDVI imagery, looking at ultralock and interlock and without DRA, ultralock was sprayed in a different direction.
Yes.
Yeah.
But that was winter weeds. It was all pretty thick. So it's not.
Yeah, but as far as wind, do you know what direction wind was out of and how high?
The wind was about 2 miles per hour.
Pretty low then. Okay. So wind probably wouldn't have been a factor there.
No.
Okay.
It was a very dead calm morning. Yeah.
Yeah.
3 maybe at the most. All
Yeah.
right.
We've got,
yeah.
He's asked about DRA effect on swath width. I've got our swath width testing that shows the CV values with and without DRA. I don't know if that'd be beneficial to pull up here. Steve?
Sorry, what was the question again? The CV,
Yeah, he was asking about DRA effect on swath width, and I've got a quick example of that on our string test.
Okay, you want to share or?
Yeah, let me pull it up real quick. I'll just do a screen
Okay,
share.
all right.
Yeah.
There you go.
Yeah. Yeah, I'll just do one quick example here. So this test, test number 24 was 2 GPA, 32 feet per second, 10 feet high, 320 micron. We used Accelerator DRA, a local provider here had that. And this was the result here. And we got a 8% CV. This is on a string test at 32 feet. And we can compare that to test number 1, which was the same parameters, just without DRA, just with water.
Yeah.
And we got a 14% CV. You can see a little bit, a little more drift on both sides actually, and a little less uniformity. So in this case, it did seem to help our
Uniform pattern.
Uniformity, yeah, for sure.
Yeah, that's right. If you do single pass testing like this, you don't want this type of up and down peak in the middle. You want to have a nice bell-shaped curve, normal distribution, that give you the lowest CV. That's a good point. And that's what we're hoping, you saw the data. Some of the DRA was able to reduce the CV of that VMD, the median droplet size, a little better than the other, So hopefully the DV10 will increase, the small droplets will be reduced, and then it doesn't add too many very big droplets at the same time. All right. Someone was also asking, you compare the hits between 2 and 3 GPA. That's a unfair or uneven comparison, apple to orange, because 3 GPA have more coverage and more hits. Yes, I agree. It is an apple to orange coverage, but also from my perspective, I'm doing operator training. So we also want more people to spray 3 GPA because it gets you more hits and better coverage because you're spraying more volume. So this is a most effective way and also very straightforward way to increase your job quality. So yes, it is our apple to orange comparison. 3GPP is supposed to do better, but from the educational perspective, you need to show people why this is a good way to go. Wonder how much different formulation types affect the spray quality. It's gonna be a long time before drones will be approved for spraying in Europe. Yeah, I agree with your second part. You know, it's getting a little better though. Some of the European countries are slowly open up drone spraying. Germany, France, and there's another country, I forgot which one, you know. UK is still lagging behind. But your first part of the question, different formulation types would affect spray quality. I'm sure the answer is yes, but there are just too many formulation types that we need to test. Right now, we're not there yet. And also, too many times we mix several different products in the tank. So you could have multiple formulations in the tank. So how do you quantify the effect of that on spray quality? You know, that will be a little different. All right, next one, it'll be interesting to test a guar or thickener type of DRA at a 2x recommended rate. And I will also reduce the hit number. And I agree, yeah, if you use too much DRA, the direct effect is you reduce the hit number per card. And that could lead to lower efficacy, depends on what you spray. Systemic chemical auxin herbicide, glyphosate, maybe not so much, but contact material definitely not gonna like it. Never too much, always great material. Thanks, Marcus. You know, you're always so encouraging, even though we always stretch too long. Where can we go watch it? I will upload the video to the website, send everyone register an email to follow up. Are all the tests with original Roto atomizer on the T40, or did y'all change the other atomizer? No, everything was original. So I believe it's the Dew atomizer. Have you noticed any correlation of what type of DRA works better through Roto atomizer in general of the drone compared to a traditional rig, TTI, fly fan, air injection nozzles? A lot of DRA designed for Dakin, but TTI nozzles, for example, do those DRA work better with atomizer? Say the oil emulsion DRA don't work well with TTIs. Well, that's quite likely, but we don't have the enough data to say that. Some of the DRA may work better with hydraulic nozzles. Oil emulsion, the types that I tested so far has not generated very impressive data on Roto atomizer. Maybe I haven't tested the right one, but it seems that polymer and guar base are taking the lead right now. So there could be differences between the types of the DRA. All right. Greg's question.
I don't know where Fred went. I think his screen just went dark on us.
Yeah.
No,
Fred,
it's dark here.
Yeah, no, I'm kidding. Yeah, you start off all nice and bright, and all of a sudden, you can barely see you down there.
yeah. Oh man, I can't believe he's doing this in the field. You know, I feel so bad.
Well, I mean, did you get
It's my
approved
field,
for
so
night
it's all right.
operations yet, or
What's that?
did you get approved for night ops yet, or
No, I actually hopped on about a half hour late because we were just finishing up
Yeah.
and I had a little break to get some of our stuff done, so we went ahead and took advantage of it. So.
Oh, you're
You
good.
can still run. I see some sunlight there in the back.
Yeah, there's
Yeah.
moon counts, right?
Oh, Taylor, where are you at? You know, it's a bright.
We're
night.
at the warehouse.
Are you at the warehouse? Is it really that
Yeah.
bright?
Yeah, I'm sleeping here tonight, Steve.
Ah, okay.
Desperate times. Well, we got visitors and we got a lot of stuff going on.
Okay, I
We
got
just got the front nozzles just came in for the T50.
you. Uh-huh.
Yeah. So we just put those on.
Gotta
Somebody-
actually check on my crew. They're still outside working, it seems.
Someone was asking about the single and dual atomizers. Steve, I kind of mentioned we played around with it a little. We didn't see much difference, but we did notice that if you're looking to get a really large droplet, you can run the single layer disc with the dual settings, and it'll lower the RPM of the
Mhm.
centrifugal nozzle by about like 700 RPM. So if there's an application where that's needed, then there you go.
Yeah.
Yeah, we do some similar tricks with the T30 like that too, to kind of get that extra control out of it. Trick the pumps into actually pumping out faster because it thinks it has different nozzle types on it, basically.
Yeah,
Yeah, it's fun.
Yeah.
you get some pretty interesting patterns.
Oh yeah, yeah, you get some pretty horrible patterns too.
Right.
Yeah.
It definitely
that's-
takes a lot of tinkering.
Yeah, and that's the problem. You can get a lot of horrible patterns. And the problem is if you don't test everything that you don't know, you're spraying with a horrible pattern, horrible
Right.
droplets spectrum, until it's too late.
Yeah,
Um,
that's why we do all of our testing first and
Yeah.
get it all knocked down first. And yeah, we don't just start throwing stuff around and call it a day.
Yeah. I think what one of your questions was on your drift program, how do you approach it? I mean, that kind of goes back to that, to where
Yeah.
it depends on what you're doing. Systemic versus not contact, that kind of thing. But also, I think the priority of the crop that you're spraying, like right now we're spraying wheat. And, for most of the products, the timing is pretty narrow. So with the weather we've been having, rain here, rain there, and then on the nice days you got wind, we don't like to go over 6-7 miles per hour, but if it's a priority and we're going to take that over not spraying, then yeah, we're just going to take a little bit longer and do it. So that kind of, I think, plays into your whole view on how you approach your drift management. So
Yeah, Rick, you want to chime in on this?
I definitely agree with what he's saying there. It's definitely situational. We have been using, I'm not going to lie to you. We haven't been using DRAs at all. This season we did decide to start. We've been trying out Windfall there, and we were getting some pretty good results with it, and we started using it with all of our operations now. However, I'm going to stop using it because I have a very slight concern it may be messing with the actual efficacy of the product, because last year, we'd have thousands of dead caterpillars, and now all of a sudden I got some of my customers from 2 days ago telling me that the caterpillars are all still alive. And I don't know if that's a bad batch of material or if this is actually affecting it in an adverse way. So I'm going to get out there and inspect it. But I mean, as far as like drift goes, though, I think I sent you very crude results. But we were testing out like at 6 gallons per acre, and we were doing it from what we do, like 8 feet, 10 feet, 15 and 20 feet. And we were getting consistent solid runs even at 7 mile per hour winds. So I was very happy with it at first, but it's all about testing, and that's kind of what we're seeing now too. But past that, I mean, our drift management program really comes down to the situation in itself. We're also usually spraying at 100 feet in the air. So, wind conditions at ground level versus up in the air on top of, evaporation concerns on top of it. There's definitely, it's a different challenge for us, but it really comes down to lowering your swath width, knowing the wind directions and the speeds. There are apps that can do wind conditions from ground level or, 20 feet, 100 feet, whatever. So it's just really about just knowing the conditions that you're spraying in for us and adjusting accordingly, whether it's swath width, speed, using the DRAs or what have you.
Or not spraying when it's blowing too hard.
Nah, just send it. You're gonna hit something.
All
I'm
right.
totally kidding on that. Please don't. We are firm believers of quality over quantity, and if the conditions start getting up where it's not going to be an ideal time for spraying, we're just not going to do it.
Yeah.
We would rather just postpone it, rather than do a half-ass job.
That's good. Taylor, any wise words you want to share about drift management in field operation?
Sorry, trying to do two things at once here.
Yeah.
Yeah, common sense, right? Common sense goes a long way. But also, I mean, I think some of the advice has been, when in doubt, use a DRA. I think it's more complicated than that. And that's what your studies have shown. So a lot more to come. We did training today, and people always ask different, questions and trying to compare what they're used to with ground rigs to drones, and how to do this, how to do that, basically. There's a lot of unknown answers, and I think there's got to be a reason that you're using a drone, right? That reason is not because you want the most uniform application. That reason is not because you want the best data, right, or whatever. That reason is because you can't do it any other way, right? And a drone air application is the method, and so there are sacrifices we have to make. It's new technology. We're all learning here, so it's only going to get better.
Yeah,
Thanks
That's
to
actually a good
and
way
thanks,
of looking
thanks to
at it.
Steve.
Yeah,
What was that, Rick?
that's a good way of thinking about that, and I've never really taken that into account myself, because we've always, kind of been under the wire, if you will, with people, expecting a perfect application every single time, as if we're, a ground rig, or, the airplanes, helicopters, which, I mean, they don't do always perfect applications too. So it's kind of that's actually a good train of thought that I've never really kind of thought of before. It's going to be one of those things. There's going to be learning curves, and at the end of the day, technology has its limits, and if we don't do a 100% perfect application on every damn square inch of the field, well, I guess we can just start telling them to suck it up again and put your ground rig in there and see what happens.
yeah. Ground rig has the highest uniformity, but area application has existed for so many years, so many decades, also for a reason. If the efficacy is not there, this will never happen. So,
Right.
and also higher variation, higher CV is just a part of the area application. You can't really change that when you spray only 2, 3, 4 GPA versus 15, 20 GPA on a ground rig. That thing is way more uniform every single time. Well, we know that. At the end of the day, it's about the efficacy. Do we kill the pest or not? If I can kill the pest with not so uniform spray pattern, maybe I can still call it good. We can improve it, but at least we secure the bottom line.
Right.
There is an interesting question here. Have you guys used a dry material called a fulminator, like a shake type of defoamer that flows on top of hot mix to kill foam? I never heard of it, but
I've never heard of it.
We've had I can't remember who it was. We had a customer that talked about using a dry defoamer, and he said he really liked it, but
yeah.
I've done it myself.
Yeah.
We use strike zone, which is kind of similar, but it's different than what it sounds like this guy's saying, but it's okay. You just got to make sure you mix it in really well.
Okay. That's a new thing, because I've always been told the defoamer water conditioner needs to go in the tank, go straight into the water first. And don't put it at the last, already you got foam, all the foam, all over the place, and dump your defoamer on the top of the foam. That's bad. But this is interesting.
Steve, I'm gonna jump.
Yeah. All right. Thank you so much, Taylor. Yeah, we appreciate
We
it.
can't even see Fred anymore, so.
Yeah, it's getting a little too long, Fred completely disappeared in the darkness.
Fred, just smile real quick. Maybe we can see your face.
Yeah, pretty sure I just heard a coyote too.
Yeah.
Like, yeah, I think
Fred,
it's time to
Steve,
go.
Rick, nice to see you guys. I'm
Nice
headed
to see
off.
you. Take
All
care.
right.
See you
Yeah,
guys.
yes.
Yeah, thank you, Taylor. Thank you. I appreciate it.
Yeah.
There are only maybe a few more questions. I think if y'all don't need to run anytime soon, maybe in 5 minutes we can finish remaining questions.
Yeah, sure.
I don't know all the answer. This guy was asking atrazine dew callisto Roundup Power Max on corn at a 3 GPA versus 10 with ground rig. Have you seen more burn from the dew? with it being more concentrated droplets. We didn't use your mix. We tried a reflex for formaldehyde, which is still pretty hot on soybean. I didn't try it on corn, but the burn herbicide kind of burns similarly. We tried a 2 GPA, 5 GPA, and 10 GPA. 5 and 10 GPA was sprayed by your ground rig, and 2 was sprayed by the drone. Actually, we saw lower burn at the 2 GPA by the same amount of reflex per acre. You know, we use 12 ounces per acre for both drone and the ground rig. So that was interesting. More concentrated droplets didn't burn worse. I don't know if y'all have seen similar thing or not.
Yeah, I haven't had any issues with, you know, more burn or less burn, really. I mean, if it might be technically a more concentrated mix, sure, but at the end of the day, it's still the same amount of active ingredient that's really, you know, going out. So, I mean, theoretically, if anything, you would think that a lower GPA would burn less because you're not coating the entire thing, you know, when you're running at, you know, 10, 15, 25 gallons an acre. But even still, I would think that it would be more or less the same. I haven't had any issues, at least.
Mhm.
I ran that actual mix that he's talking about. And the only thing I noticed would have been the Callisto portion. I feel like the Callisto may have shown a little bit more cosmetic symptoms than, you know, through a ground rig. But as far as, and even then it's just cosmetic, so it's not like a burn from the Callisto. But yeah, I haven't seen anything burn wise, kind of like you guys have already said. But the one thing I did notice is with when Callisto's in the tank on a 2 or 3 gallon per acre rate versus, you know, 15 or 20 even, I do see a little bit more burn, or that kind of ghost white leaf that you see with Callisto.
Okay, all right, good observation. Apps for measuring swath width. I mean, technically you can do this with water sensor paper, swath gobbler, and multiple options. You just need to use the software to figure out the optimum overlap. Depends on what type of CV you use, you know. Mark was asking, your coverage was much higher with 3 GPA at a larger droplet spectra. Do you think the swaths contracted in those 3 GPA higher droplet size application? That would explain much higher coverage. Maybe we didn't really measure the swath width, you know. I know the variation was higher with those 500 micron applications, so that could be true, you know. That something has happened with the swath width. Swath width may be reduced with 3 GPA, 500 micron, very big droplets. Also, your results showing DRA have very little effect on rotary atomizer in many scenarios are consistent with the work has been done with other rotary over my career. Well, that's good. That's good. Consensus is always good. Steve, is there a plan of any info on 2025 end user conference? No, I wish I could.
Already asking about the conference, huh?
Oh yeah, that's a good
Yeah,
one.
well, you said it was going to be in the Bahamas this year.
Oh, well, yeah, Bahama, Hawaii, you know,
Yeah.
all those good places. Yeah, I heard it'll be good, but yeah, I'm sorry, I haven't started thinking about it yet. You know, we're so busy
Yeah,
with field
it's definitely
trials.
way too early for it, but you know, I think everybody is going to be excited for it. I mean, the last one was definitely a huge success, and
Uh,
yeah, and a lot of people are talking about it. So yeah,
yeah,
definitely looking forward for that.
yeah.
Welcome back, gentlemen.
If you need to either slow down or take a narrow swath to achieve 3 GPA, which would you prefer? So this might be the last real question we need to answer. I go with narrower swaths on row crops. On row crops, I go with narrow swaths. I'm not gonna slow down. Slow down also means my swath width with effective swath width will be slower as well. So I'd rather set the narrower swath proactively that way versus slow down and use a wider swath which creates my own streaking. Because the faster you fly your drone, the further propeller downdraft is gonna push, not propeller downdraft, further that velocity is going to, and also the vortex will push everything sideways. This is why when you fly real slow, you see a beam of droplets coming straight down, and there's not much of movement on the edges, push things outside. So I want to fly fast, but I want to reduce the swath, to reduce streaking. So that's usually my answer. What do you think, Rick?
Yeah, no, you're 100% correct on that. It's if, especially in any sort of like wind conditions, or if you are kind of bumping up the GPA on that, you definitely have to adjust your swaths. In most cases, I mean, I don't think I usually go over a 20-foot swath in most of my applications in general. And obviously we kind of run it a little bit, less than that, but once again, we're usually 100 feet in the air. But even on row crops and things like that, if we have perfect wind conditions, I mean, sure, we'll break out the big boys and we'll have a 50-60 foot swath on the thing. But as soon as any sort of wind starts coming up, then those ones we dial it back, I think, to around 40 feet. But it's less swath is always better for us, in my opinion. Just to make sure that you get that uniformity, because if you're trying to spread it that far, it's just you can't always guarantee that you're going to get that far, and then you could be leaving huge gaps. So yeah.
Very good point. Yeah. Yep. Fred, do you want to jump on this, or you're good?
Oh, hey, we can see Fred again.
Yeah, I got the truck now. Yeah, no, I think Rick hit it on the head. I mean, it's obviously as you slow down, it gets narrower. So, but it depends on what you're doing. I mean, for him being up that high and the wind being as strong as it is up there compared to at ground level, it's a little bit more important. In the row crops, as soon as I kind of want to refer back to your post the other day where you kind of laid it out there, how you had your settings, Steve. That's almost it's almost spot on as far as kind of how we set it. As the wind starts picking up, we just start narrowing up, and we've gone as narrow as 15 feet. It's not from a application standpoint and trying to get acres in a day. You're not getting acres in a day, but at least the thing's still moving. But again, it's because of that priority of getting that field done because of the weather, not so much, trying to get as many acres in that week. It was that was the priority. It was already behind, and it's just kind of the cards we were dealt with. But obviously, if you can still keep that same swath with, that'd be great. But you're just not going to. The wind picks up above. For us, it gets above 7-8 miles an hour. We're really questioning whether we should be out there or not. And we're running pretty low, pretty narrow at that point anyway. So that's where I think, getting the nighttime exemption would be pretty helpful, being able to get out there earlier before daybreak and take advantage of that calm morning, and then take a break during the day, the midday, and then come back in at night. But again, it's situational.
Yeah, so situational. A lot of folks want to spray at night, and I agree, wind is calm, humidity is higher, temperature is lower, evaporation is lower. But the issue is always the temperature inversion, that's one thing EPA and Registrar are very cautious about, morning is worse in terms of temperature inversion than the afternoon, or the late afternoon, because late afternoon usually when it starts to form, and it's worse, the inversion later is strongest right before the sunrise. But you had a great point, and I really like, you have to reduce the swath and sacrifice your efficiency to spray in the windy condition, and at some point it's just not worth it to keep pushing. It's not worth it, So.
Yeah, it only takes one potato patch to really mess something up, or a streaky field. Yeah, and then that's just gonna put your business at risk, really.
Mm-hmm.
Yeah.
Exactly. All right. I think we were able to wear everyone out. I don't see more questions, I may have missed one or two questions, and I did a terrible job in the Q&A. I feel like, it was just a lot of discussion among us, and then, answer some question here and there. But Yeah, everything's recorded. So if you want to watch it later, you know, it'll be available pretty soon. I will send an email to all the folks register with the link so you can click on it and watch it whenever you drive somewhere. You know, I don't think many people will stay in the office and watch this thing for 2.5 hours, but all right, last comment, comment, gentlemen. Anything you want to say, or we're good?
No, it's I mean, I think we've pretty much covered everything. You know, it's definitely I do believe that a lot of this has to kind of become a standardized type of system. You know, there definitely has to be a lot more research done, which quite frankly, Steve, that's kind of your domain in this entire industry. I believe is you're pretty much spearheading all of that. You know, the rest of us are, you know, we're kind of focused full time doing spraying pretty much sun up to sundown the entire year here. So we kind of can't really a lot of times actually focus to sit down and, you know, do all this testing and then put together actual data that can be digested by people. It's more everything that we do that we mark down is all just internal. A lot of it's kind of just written down on a notebook. You know, but as far, you know, I do think that we kind of need to get a lot of this industry standards kind of hashed out long term for to kind of help everybody, you know.
Yeah, that's a great saying.
Yeah, it's about like everything else in ag. There's a little bit of art to the science, and there's you could probably research, you know, for the next 10 years, and we might be a few steps closer, just because there's so many variables that we're dealing with and so many different situations to where a baseline standard though would be just huge, or at least, you know, best management practice, because we don't have the time to do that right now. We're trying to fill the demand on application, and we're learning kind of on the go. But you know, if you're an operator, just pay attention to what you're doing. You know, don't just get stuck on these are the settings and go. You'd have to kind of use your eyeballs too, and not just the screen. And you know, you get over 7-8 miles an hour of wind, you got to kind of wonder if you should be out there or not, depending on what you're doing. So
Yeah.
it takes one potato patch, and then that's when the complaints start coming in. So
All right.
we don't want that.
That's what I remember at the end of the day. It only takes one potato patch.
Yes.
That
Yeah,
was
one potato patch.
most useful information I learned from today. Yeah. Mhm. But great, that's a great experience for all the operators, especially the new ones, you know, just getting into the industry. All right. All right, I think that's it for today. I mean, I'm always a liar. I say this thing takes 2 hours, and now it's pretty much a 2 hour 40 minutes. You
Yeah.
know, I feel like if we have a few beers in front of us, we maybe keep talking for another hour, you know, easily on this.
Yeah,
Yeah.
probably. Well, unfortunately not for us because, you know, we got to get up
Yeah.
at like 4 a.m. and start our day.
Wow.
And 4 a.m. for us is in like 6 hours from now.
Yeah.
So, yeah, we can't stay and talk anymore.
Yeah, I know. Well, thank you all so much for squeezing out time in your busy schedule to do this. You know, I really appreciate it. I know this is not a convenient time of the year for you all, but I think some of the message probably need to get to the operator before the season fully start, or at least before I get to the peak,
Right.
you know, so people can
Yeah,
think
no,
about it.
absolutely. We're at least happy to help, Steve. You know, you put in a lot of time and effort yourself, so you know it's kind of the least we can do is show up every once in a while for an hour or two and you know, do some talking with you. So
All right. Thank you so
Yep.
much.
Thank you.
yeah,
All
thanks a
right.
lot, guys. We're gonna run here, so we'll see you guys.
See ya.
Yep. Have a good night.
Yeah, you too.
Yep.